Okay, so we were talking about the two uh, models, the uniform wear model and the uniform pressure model. Now, in case of uniform wear model, as we said that your PA times RI, that is constant. ठीक है जी? Because this is basically the maximum pressure. The pressure will be maximum over here since the radius is minimum over here, because our pi, if the pressure is pi over here, and we would say that is maximum because your ri is minimum over here compared to the pressure over here, which is your p naught or not. So basically what I mean to say is that your R naught is maximum over here and Ri is minimum. Therefore, your P will be maximum over here and minimum over here in the uniform wear model. Now, let's see, how do we calculate or actuation force F using the uniform wear model, and how do we calculate our T, which is the torque. So this is the actuation force. um, Actuation force, और ये हमारा क्या है, transmitted torque in using this type of clutch. ठीक है जी? अच्छा, सबसे पहले, since we have selected this dr, ठीक है जी? So can we write the area of this differential area? What is the area of this differential strip? ठीक है जी? इसका area क्या होगा? Can I say that it is going to be the circumference, which is 2 pi r, ठीक है जी, multiplied by the thickness of the strip, which is dr. So this is my area. ठीक है जी? Now, what will be the force? देखिए, फोर्स को अगर हम कैलकुलेट करना चाहें, इस फोर्स को, सिंस इट इज अप्लाइड परपेंडिकुलर टू दैट, तो ये फोर्स क्या होगा? इज इट नॉट गोइंग टू बी प्रेशर टाइम्स एरिया? ठीक है जी? Now, so this, if we are talking about the differential area, then my df is going to be equal to 2 pi r, well, let me just add the pressure too over here. ठीक है जी? वो area, ठीक है जी, 2 pi p r dr. ठीक है जी? Is this good? Okay, 2 pi p r dr. Now, if I want to find out f, I have to integrate from d by 2 to d by 2, and 2 pi p r dr. Now, let me write this over here. Can I write that as f equal to मेरा जो, let's take out the constants out. So 2 pi is constant, 2 pi, and what about PR? Isn't that a constant too? ठीक है जी? Let's take that out. So if I write PA, which is the maximum pressure, can I write RI, and RI is equal to D by 2. ठीक है जी? D by 2, and then integration from D by 2 to D by 2, what is left over there is r dr. ठीक है जी. और यहाँ पे अगर आप देखें तो this 2 is going to cancel with this 2, so your f is going to be pi pa d. ठीक है जी. और यहाँ पे अगर मैं इंटीग्रेट करूँ इसको तो दिस विल बिकम r स्क्वायर बाई 2, और लिमिट्स होंगे आपके d बाई 2 और d बाई 2. ठीक है जी. तो नाउ आई कैन फाइंड आउट माई f फ्रॉम हियर. तो f मेरा क्या बन जाएगा? लेट्स लुक एट दैट. माई f इज गोइंग टू बी ये बन जाएगा. ठीक है जी. अगर मैं इसको इंटीग्रेट करूं, ये सिंस आई टुक पी ए डी आउट, तो ये मेरा f बन जाएगा इफ़ आई पुट द लिमिट्स d बाई 2 और d बाई 2 अगर मैं पुट करूं तो दिस इज़ माई एक्चुएशन फोर्स. ठीक है जी. ये क्या होगा? एक्चुएशन फोर्स. ठीक है जी. नाउ व्हाट अबाउट टॉर्क? टॉर्क इज इक्वल टू फोर्स मल्टीप्लाइड बाय रेडियस. अच्छा जी. फोर्स इस केस में हमारे पास क्या होगा? इट विल बी फ्रिक्शनल फोर्स. ठीक है जी. फ्रिक्शनल फोर्स. तो व्हाट इज द फ्रिक्शनल फोर्स? इट विल बी एफ टाइम्स जो हमारे पास नॉर्मल फोर्स है, एंड दैट इज एफ एफ. ठीक है जी. तो एफ एफ होगा. बट नाउ फॉर द डिफरेंशियल फॉर द डिफरेंशियल स्ट्रिप, अगर हम टॉर्क कैलकुलेट करना चाहें तो दैट विल बी डी टी विच विल बी इक्वल टू फोर्स. एंड व्हाट इज दैट फोर्स इक्वल टू? वी ऑलरेडी नो कि वो फोर्स जो है वो प्रेशर टाइम्स एरिया के बराबर है. तो एफ टाइम्स 2 पाई पी आर टाइम्स, इसको मैं ये आर से भी ज़रा दे देता हूँ. ठीक है जी. 2 टाइम्स, बिकॉज यहाँ पे आपका एक आर और भी होगा, तो 2 टाइम्स पी आर टाइम्स आर डी आर ऐसे होगा. राइट. सो वी कैन राइट दिस एज we can write this as 2 pi f p r square dr. This will be our dt. ठीक है जी. Or I can say it will be t if I use this limits d by 2 से लेके d by 2. ठीक है जी. And that equation is over here. ठीक है जी. So what I would do is basically in this PR, I can split this into PR times r, and this is constant. So let's take out the constants out of the integral sign. 2 pi nikal jayega, f will also go out, and pr is also going to go out. So the only term that is left in integration is rdr, and if I integrate that, then this is my torque. Okay. This is the torque transmitted. Similarly, if I want to write this in terms of f, so basically what I would do is I will split this equation into, or I'll write this as pi pa d f by 2 times 4. ठीक है जी. D square d minus d, so I'll write this d plus d into d minus d. ठीक है जी. तो यहाँ पे if you look over here, isn't this मेरे पास जो है this thing. ठीक है जी. including this d minus d, isn't this equal to f? तो इन सब की जगह अगर मैं f डालूं तो that will be f, फिर ये वाला f. ठीक है जी. so that f, और ये d plus d वाला टर्म, so that is the d plus d, और ये 4. so this is the torque in terms of what? इन टर्म्स ऑफ फोर्स। ठीक है जी। तो ये अभी हमने क्या कैलकुलेट, अभी हमने क्या किस चीज़ के लिए फार्मूले जो है वो डिराइव किए, द एक्चुएशन फोर्स एंड द ट्रांसमिटेड टॉर्क इन केस ऑफ यूनिफॉर्म वियर। ठीक है जी, यूनिफॉर्म वियर। अच्छा, अब हम क्या करते हैं, लेट्स टॉक अबाउट यूनिफॉर्म प्रेशर। देखिए यूनिफॉर्म प्रेशर में हमने क्या कहा कि द प्रेशर विल रिमेन यूनिफॉर्म थ्रू आउट। That's the case, then it is really easy. Force is equal to pressure multiplied by area. ठीक है जी। तो the pressure is PA, which remains the same throughout, multiplied by the area. Area A of a donut is pi by 4 times d square minus d square। ठीक है जी। तो ये आपका equation जो है, this is for the force, actuation force, which is this one। ठीक है जी। Now we also can find out the torque, since for the torque हमारे पास फोर्स जो है that will be 2 pi f p। ठीक है जी। 2 pi f p from the same formula here, जो जो अभी हमने जिसकी बात की। ठीक है जी। 2 पाई एफ पी टाइम्स जो है आर स्क्वेयर डी आर। ठीक है जी। And if I want to find out t, so I have to integrate this from d by 2 to d by 2। ठीक है जी। So again, go ahead and integrate this, but take the constants out. This is constant, this will go out, this will go out, this is going to go out, and p is going to go out. So 2 pi fp times, अच्छा जी, r square is going to remain there, d by 2, and then d by 2 r square dr. So when we integrate that, 2 pi fp r cube by 3 d by 2 and d by 2। ठीक है जी। So this is going to be my torque now, putting the limits. My torque turns out to be pi fp over 12 d cube minus d cube। ठीक है जी। और in terms of force I can write this as f over 3 d cube minus d cube over d square minus d square। ठीक है जी। तो what did we do, we used two models, and in for those two models we found out the torque and the actuation force for both, for an axial um, single plate clutch। ठीक है जी। um, okay, now we have another अच्छा जी, I also told you that these two models जो हमारे, okay, so as I said that the uniform wear model, uh, that is used for old clutches। ठीक है जी। or when the clutch becomes old, then the uniform pressure model is the one for a new clutch, or when the clutch is new। ठीक है जी। Now if you look at them, there is not much difference between these two। अगर आप यहाँ पे देखें तो दिस पैरामीटर टी ओवर एफ एफ डी, और यहाँ पे प्लॉट किया गया है योर डी बाई डी, प्लॉट किया गया है। इफ़ यू लुक एट दिस, तो दिस डी बाई डी, and this is how the uniform pressure model would look like। ठीक है जी। and if you see over here, they both become the same after। ठीक है जी। this almost यहाँ पे। ठीक है जी। So there is not much difference between these two models, but this is just a representation of this. Okay, these are the two models. Now let's come to another type of brake, which is known as the disc brake or disc brake. आप लोगों ने देखा होगा अमूमन फ्रंट व्हील गाड़ियों के फ्रंट व्हील में, and it looks like this, almost look like this. ठीक है जी, अगर आप देखें तो ये this is your front wheel. यहाँ पे your tire is attached with these four let me see, with these four lug nuts. एक, five actually, 1, 2, 3, 4, 5, and this is the disc. देखिए ये आपको जो शाइनी नजर आए, this is the disc. ठीक है जी, and on this disc there is this brake pad that is attached, and the brake pad, if you have seen it, it looks like this. Um, so it is on both sides, and in this figure, this is a little bit detailed figure. In this figure, it is shown over here, and it is also shown over here. So sorry, over here. This is the disc. Uh, Disc that this one. ठीक है जी. Similarly, यहाँ पे अगर if you look over here, this is hydraulic. So the brake fluids basically apply force on the brake fluid apply force on this side and on this side. There is a piston basically. So this side is fixed, or when you apply force on this side, so the disc is sandwiched between these two um, pads. ठीक है जी, फ्रिक्शन पैड्स यहाँ पे, this is the frictional pad. ठीक है जी. Anyways, what you would do is you will apply force on this again. What we are going to do in this case is we are going to find the actuating force. We are also going to find the um, torque transmitted. ठीक है जी, yeah, the torque. And we are going to use both models, the uniform wear model, um, and the uniform pressure model. ठीक है जी. So the uniform wear model and the uniform pressure model. If you look at the geometry of the contact area of the brake pad, so this looks like basically it looks like this. Okay, you see here, this is the brake pad. ठीक है जी, yeah, the frictional pad. ठीक है जी, the pink that you see over here, and it is on both sides, on this side and on this side. ठीक है जी. Here is the disc. This is the disc over here. This hole is disc. ठीक है जी. And the disc actually rotates with the wheel or with the tire, and then when you press this pad against the wheel, it is going to stop the wheel and apply brakes. ठीक है जी. Now let's say that we have the inner radius is Ri and the outer radius over here is R naught. ठीक है जी. And this annular, the brake pad starts at some angle theta 1, and then it goes up to angle theta 2. ठीक है जी. So the angle that it covers is basically theta 2 minus theta 1. ठीक है जी. Now, in order to analyze this for the force and the torque, first of all, let's do this. कि हम क्या करते हैं कि let's say कि हम यहाँ पे consider a very small यहाँ पे एलिमेंट हम कंसिडर करते हैं एंड लेट्स से दैट दैट एलिमेंट इज समवेयर हियर, ठीक है जी। लेट्स कंसिडर दिस एलिमेंट ओवर हियर, ठीक है जी। एंड लेट्स से दैट दिस एलिमेंट sorry let's say that this element goes from some sorry, let me draw it again, okay, because oops. Okay, let's say that somewhere कहीं पे भी आप ड्रॉ कर सकते हैं, this small element, and let's say that this small element extends at some angle theta, ठीक है जी। एंड the thickness of it on this side is dr और इसी तरह ये d theta, ठीक है जी। हम ये कंसिडर कर लेते हैं, चलें। तो if this is कहने का मकसद ये था कि अगर हम if we are considering this small element, ठीक है जी, that has this side d theta, ठीक है जी, and this side as dr, यहाँ से यहाँ तक, ठीक है जी, and this from here to here, ठीक है जी, this is d theta. So now what we can do is what will be the force, what will be the force, again the force is equal to pressure multiplied by area, ठीक है जी। तो in this case we are moving in two directions. एक हमारे पास the change is in d theta and dr, but what is going to be the area of this element? So area, what will be the area? Can I say, देखें ऊपर वाला portion जो है, since this is an arc, तो that will be, एक तो ये होगा कि d r d r, the area will be r d r d theta, ठीक है जी। ये आपका एरिया हो गया एंड मल्टीप्लाइड बाय क्या, मल्टीप्लाइड बाय प्रेशर, ठीक है जी। तो पी आर डी आर, ठीक है जी, पी आर डी थीटा। now and that is going to be the differential force df, ठीक है जी। अगर हम f मालूम करना चाहें तो what are we going to do, we are going to do double integration and that will be p r dr d theta, ठीक है जी, and integration from theta 1 to theta 2 and r naught ri to r naught, ठीक है जी। तो थीटा 1 से लेके थीटा 2 तक एंड आर आई या आर 1 से लेके आर 2 तक, वेल आर आई से लेके आर नॉट तक, ठीक है जी। सो दिस इज गोइंग टू बी आवर फोर्स। नाउ सिमिलरली, अच्छा चले इसको ज़रा थोड़ा सा सिंप्लीफाई करते हैं। सो दिस विल बी इक्वल टू, लेट्स इंटीग्रेट विद रिस्पेक्ट टू आर डी थीटा, ठीक है जी। अगर डी थीटा अगर हम इंटीग्रेशन करें तो व्हाट विल वी हैव, विल हैव क्या, पी आर, बल्कि यहाँ पे ऑलरेडी लिखा हुआ है, आई नॉट कि इफ वी इंटीग्रेट विद रिस्पेक्ट टू थीटा सो इट विल बी थीटा थीटा, डी थीटा का क्या इंटीग्रल होगा, थीटा, सो theta and putting the limits from theta 1 to theta 2 minus theta 1 times p r d r r I to r naught, ठीक है जी। ये हमारा इक्वेशन 16-29 हो गया, ठीक है जी। नाउ सिमिलरली हमारा जो t है which is the torque that will be the coefficient of friction multiplied by the force, which is the normal force. ठीक है जी. तो normal force हमारे पास क्या है? P times R D P times R d R d theta. Well, I'll write this down. ठीक है जी. F times P R, ठीक है जी, d R d theta times R, which is the radius. So this will become torque. ठीक है जी. ये हमारे पास normal force multiplied by the coefficient of friction. So this will become frictional force multiplied by R. That becomes the torque. Also integrate this with respect to theta. So it will be theta 2 minus theta 1. Take the coefficient of friction out because that is constant. हमारे पास रह जाएगा P R square d R. ठीक है जी. अच्छा. Now one more thing. देखें, let's say I'm talking about an equivalent radius. मतलब देखें, what will be the equivalent radius of this pad in order to have that torque T. ठीक है जी. तो उसको मैं RE कह देता हूँ. If I call that RE, तो टॉर्क मेरे पास क्या होगा? Wouldn't it be the coefficient of friction multiplied by F multiplied by RE? ठीक है जी. या can I say कि RE is equal to T divided by F. ठीक है जी. अच्छा, I know the value of T and I know the value of F from the above two equations, equation 16-29 and equation 16-30. तो लेट्स पुट those values. ठीक है जी. अगर वो वैल्यूज मैं पुट करूं यहाँ पे, तो मेरे पास क्या होगा? थीटा 2 माइनस थीटा 1, ये वाली वैल्यू मैं पुट करूंगा. ठीक है जी. थीटा 2 माइनस थीटा 1 टाइम्स एफ from Ri to R naught P R square dr divided by F. ठीक है जी. F, और इस F की क्या वैल्यू है? इस F की वैल्यू ये है थीटा 2 माइनस थीटा 1 टाइम्स integral from Ri to R naught P R dr. ठीक है जी. अच्छा, this is going to cancel with this one, this F is going to cancel with this F, और मेरे पास क्या रह जाएगा? ये डिवाइडेड बाय दिस. ठीक है जी. तो ये मेरी RE की वैल्यू आ गई. अच्छा, ऑल्सो वी नो कि हमारे पास mx जो है, या मोमेंट. अच्छा, and let's look at that. What will be the moment? Moment will be F applied multiplied by the perpendicular distance. देखें, यहाँ पे आप देखें तो this is our R bar, right? Now this R bar and the force is applied over here. So what will be the moment? F times R bar. लेकिन R bar जो है, that depends. देखिए, R bar is the perpendicular distance. Now if I'm talking about here, तो यहाँ पे perpendicular distance क्या होगा with respect to R? It is this one. If I'm talking about this point, तो मेरा perpendicular distance क्या होगा? This one. ठीक है जी. तो it depends on the angle that I'm talking about. ठीक है जी. ये इस एंगल पे डिपेंड करता है. सो व्हाट इज दिस, व्हाट इज द आर कंपोनेंट इफ आई हैव दिस एंगल थीटा? अगर ये मेरे पास हो, तो देन दिस कंपोनेंट या द परपेंडिकुलर कंपोनेंट, ये वाला जो कंपोनेंट है, द परपेंडिकुलर कंपोनेंट इज बेसिकली आपका आर बार क्या होगा? दैट विल बी इक्वल टू आर R sin theta, कोई भी R हो, at whatever radius, it's going to be your R sin theta. So it will be P R sin theta, that is R sin theta is the value of R bar, dr d theta, which is F. ठीक है जी. तो F की वैल्यू मैंने डाल दी, and when I integrate that becomes cos of theta 1 with respect to theta minus cos of theta 2 एंड इनसाइड इंटीग्रल पी आर स्क्वायर डी आर। ठीक है जी। तो और आई कैन से कि मेरा आर बार जो है, ठीक है जी, सिंस आर बार इज एम एक्स ओवर एफ, तो एम एक्स की वैल्यू आप ये डालें, दिस इज योर वैल्यू ऑफ एम एक्स, ठीक है जी, एंड पुट द वैल्यू ऑफ एफ। तो एफ की भी वैल्यू डालें तो वो बाकी चीज़ें कैंसिल भी है, इंटीग्रल ऑफ फ्रॉम आर आई टू आर नॉट एंड पी आर स्क्वायर कैंसिल हो जाएगा आपके वो एफ के साथ, and and you will be left with cos of theta 1 minus cos of theta 2 over theta 2 minus theta 1, बल्कि यहाँ पे तो टाइम्स आर ई ये बन जाएगा। ठीक है जी। तो now we have the equations for the actuation force, the torque, the equivalent R, the moment and R bar. Now, लेकिन इसमें हमने we have not considered yet that what model are we going to use. Now, if we are using the uniform wear model, तो देखें for uniform wear model what we are going to do is let's say यहाँ पे let's say let me use red, ठीक है जी, uniform wear model, and I'm going to take this equation and calculate the uniform wear model. Say I'll calculate F. So F will be equal to theta 2 minus theta 1 यहाँ से। ठीक है जी। अच्छा, in uniform wear model PR is going to be constant, तो ये PA R is D by 2 और अंदर क्या रह जाएगा, आर आई से लेके आर नॉट तक क्या रह जाएगा, इंटीग्रेशन करेंगे तो डी आर रह जाएगा। सो आई कैन इंटीग्रेट डी आर एंड दैट विल बिकम आर। ठीक है जी। तो आई कैन फाइंड माई एफ फ्रॉम हियर। इसी तरह टी में टॉर्क जब मैं मालूम करूंगा तो आई टेक इसको मैं स्प्लिट करता हूं, दैट विल बिकम पी, दैट विल बिकम पी R times R. So this will become constant. It is going to go out of the integration sign. और यहाँ पे R रह जाएगा. When I integrate this will become R square by 2. ठीक है जी। तो that is what I'm going to do. और अगर उसको मैं करूँ तो these are the final equations for the uniform wear model, and similarly torque for the uniform wear model. ठीक है जी। और मेरे पास आर, अच्छा आर ई में जस्ट पुट द वैल्यूज, ठीक है जी, फॉर द यूनिफॉर्म वेयर मॉडल। तो आर ई आपके पास आर नॉट प्लस आर आई, बेसिकली इट इज द एवरेज ऑफ द टू। ठीक है जी। तो आर ई भी आ जाएगा। इसी तरह आर बार में भी आप वैल्यूज डाल उसी इक्वेशन में, तो यू विल फाइंड द वैल्यू ऑफ आर बार। ठीक है जी। सो दैट वाज फॉर यूनिफॉर्म वेयर। यूनिफॉर्म प्रेशर मॉडल अगर आप इस्तेमाल करते हैं तो यूनिफॉर्म प्रेशर में योर पी ओनली कम्स आउट, आर रह जाएगा, एंड व्हेन यू इंटीग्रेट दैट दिस इज योर एक्चुएशन फोर्स, similarly this is your torque, and the value of re and the value of r bar। ठीक है जी। so this is using both models, and both models for the disc brake। ठीक है जी। for disc brake, ठीक है जी, we used both models to find out the actuation force and the torque। ठीक है जी। okay, now let's look at this example। this problem says that two annular pads This means that it's a disc brake with आर आई इक्वल टू, तो देखिए आर आई हमें दिया हुआ है, दैट इज 3.875 इंचेस, आर नॉट is 5.50 inches, subtended at an angle of 108. ठीक है जी, तो एंगल that it is subtended by that is 108 degrees, have a coefficient of friction equal to 0.37. ठीक है जी, and um, and are actuated by a pair of hydraulic cylinders 1.5 inches in diameter. So the diameter of the cylinders, ठीक है जी, that is 1.5 inches. I'll write the DC, ठीक है जी, which is the diameter of the cylinder. The torque requirement is 13,000 pound force inch. So the amount of torque that we would need is 13,000 pound force inch. ठीक है जी. For uniform wear, he says use the uniform वेयर मॉडल. ठीक है जी, यूनिफॉर्म वेयर मॉडल इस्तेमाल करें एंड फाइंड आउट द लार्जेस्ट नॉर्मल पी ए, द एस्टिमेट द एक्चुएशन फोर्स एफ मालूम करें, find the equivalent radius RE and the force location R bar and estimate the required hydraulic pressure. ठीक है जी, सबसे पहले if we come to the solution, तो सबसे पहले we know कि हमारे पास बेसिकली यूनिफॉर्म वेयर मॉडल के लिए अगर आप इक्वेशन 16-34 देखें, या यू शुड रिमेंबर दिस, कि आपका टॉर्क जो है, टॉर्क इज इक्वल टू 1/2 थीटा 2 थीटा 2 माइनस थीटा 1 एफ पी आर आई and r naught square minus ri square. This is your equation 13-24. ठीक है जी, तो from here we can find out this PA, which is the largest normal pressure. ठीक है जी, so go ahead and find out this largest normal pressure. Your PA will be equal to 2T. ठीक है जी, 2 torque, and this, you already know the values of the torque, the angles, and the R naught and R naught square minus R I square. ठीक है जी, already आपको पता है. You already know these values. ठीक है जी, this is basically 108 जो आपको दिया गया है, that is 108 and multiplied by pi by 180 to change it into radians. ठीक है जी, and then 0.37 is the coefficient of friction, your Ri and the difference between Ri and R naught. ठीक है जी. Now so you will get PA from here. For part B, you go ahead and put the values in equation 16-33, which is the actuation force. Actuation force malum kare, that is 3748 pound force. From equation 16-35, you can find the value of RE. Similarly, you can go ahead and find your R bar. अब ये चीज़ें मालूम हो गई हैं. We can also find out the actuation, जो सिलेंडर या हाइड्रोलिक प्रेशर कितना चाहिए. बेसिकली प्रेशर इज इक्वल टू एफ बाई ए का ना, तो दैट विल बी द एरिया ऑफ प्रेशर. ठीक है जी, तो सिलेंडर का उसने डायामीटर हमें बताया था, द डायामीटर वाज 1.5, सो द एरिया ऑफ द सिलेंडर इज पाई बाय 4 d square and your d is 1.5. ठीक है जी, or actuation force we already know, we have calculated this in part B, जो कि हमारे पास 3748 pound force divided by the area, and that is 21 psi. ठीक है जी. So your hydraulic pressure should be 21 psi in order to get the torque requirement and for that actuation force. ठीक है जी. Now that was another uh, uh, brake, type of brake. In this brake, there is also a type which is known as a circular pad, or well, it has a circular pad or a caliper brake, इसको हम कहते हैं. ठीक है जी. So instead of this pad, जो हमारे पास इस किस्म का, सॉरी, जो हमारे पास इस किस्म का पैड था, we have a circular pad. So this is known as a caliper brake, and if you remember these dimension, well, this dimension is E, and this is R, and again this is standard. For the analysis of the caliper brake, your RE, these formulas are already given to you, no need of. R is equal to delta E, your F is equal to pi R square P average, and your T is equal to FRE. Now what is delta? जो इक्वेशन 16-41 में इस्तेमाल हुआ है, you can get it from this table. Parameters for a caliper brake, ठीक है जी. This is your R by E and P max or P average आपको दिया गया है. So you can use these values. This example, it says that a button pad, the same, the circular pad, ठीक है जी. Disc brake uses dry sintered metal pads, and the pad's radii is 0.5 inches and its center is 2 inches from the axis of rotation, 1 by 2 inches in diameter disc. ठीक है जी. Using half of the largest available pressure, P max is 350. Find the actuating force. तो हमने क्या मालूम करना, F and the brake torque and the coefficient of friction. Well, you already have formulas over here. You just need to plug in these values in there. Since the pad radius is 0.5, ठीक है जी. तो आपका R जो है, R over E क्या हो जाएगा, that will be 0.5 and eccentricity is 2. तो ये आपका R by E ratio हो जाएगा 0.25. From 16-1 you go ahead and find your R by E आपका कितना है, 0.25 है. ठीक है जी. तो 0.25 यहाँ पे कहीं आपकी वैल्यू होगी. ठीक है जी. So go ahead and find your value of delta. ठीक है जी. P max over PV, P average मालूम करें, and follows that RE जो है that will be equal to delta times E, that is your RE, the effective, the equivalent radius, और P average भी आपको पता चल जाएगा यहाँ पे because you know the value. तो P max उन्होंने दिया है, that is 350. वो कह रहे हैं half of that, so that is 350 by 2 and 1.29, which is 1.35. Actuating force कितना होगा, we already know the formula, F is equal to pi R square P average. Putting the values, that is 106.6, and your T is equal to 63.65. And this is on one side, ठीक है जी, on one side of the. So that was about the disc brake, either the annular or the circular disc brake. ठीक है जी. The pads are okay. Now there is another type of clutch which is known as the cone clutch. And how does the cone clutch work? Though there is this figure, let's say that we have the engine over here, or a power source over here, or a prime mover, and uh, this is rotating this shaft. So to one side of this, to this shaft is attached um, a, a cup. Okay? So this is the cup that is attached to the engine. For example, this is your engine, and there is a shaft coming out, and then we have a cup over here, right? Now, in this cup goes in a cone, and if you look at this black drawing over here, the one that I marked with red, that is frictional material. Now, so the cup goes, the cone goes into the cup, and that frictional material comes in contact with this, and if this is moving, right, so that power is transmitted to a shaft which is attached with the cone. ठीक है जी. So if this is rotating in this direction, this is also going to start rotating with that once it is engaged. I would rather share another picture with you. uh, जैसे ये ठीक है जी. In this picture you can see that this spring is basically the actuation spring, right? And if you apply, if you put force over here on this pedal, this is going to bring the clutch out and disengage it, right? So basically this is the cup, which is also known as the outer cone bhi aap keh sakte hain, and this is the inner cone. So the inner cone and the outer cone basically engage and disengage with each other with the help of this actuation force that you apply. There it is spring loaded so that it stays in there, but if you apply this uh, force on the pedal, this will come out and disengage, and there will be two separate parts. The again, this is the frictional lining, the frictional material, and as I said, that this is one of the oldest, the earliest clutches. It has been used a lot, probably I would say in the 80s, 70s, and so on. Uh, uh, the cars or the automobile has used this a lot, and again, it is used in many systems. In order to find out the actuation force, the only difference is, again, you will have a frictional surface. The only difference is that since the frictional surface is not, it is not of uniform diameter, but it gradually it increases. ठीक है जी? So if you take a strip, a small strip, that strip is not going to be even, but it is going to have to be different as you go along. ठीक है जी. तो इसका ये जो हिस्सा है, that is inclined. ठीक है जी. So as opposed to this one, so it is inclined, and due to that inclination, if the cone angle is alpha, matlab 2 alpha basically, and half of it is alpha, तो आपका ये जो load है ना, that is PDA, and basically ये जो यहाँ पे ये distance है, this is not just dr, but it is dr over sine of alpha. So you have to use this value of dr. Again, आपका pressure फिर क्या होगा कि it will be equal to PAD over 2R. ठीक है जी. और यहाँ पे आप जो area लेंगे, that will be accordingly adjusted due to the angle alpha. ठीक है जी. The rest of the things are the same, कि आप actuation force मालूम करेंगे, you will have to integrate that. I'm going to leave this for you guys, कि derive equations for the actuation force and torque using both models, uniform wear and uniform प्रेशर मॉडल। ठीक है जी, तो ये मैं आप लोगों पे छोड़ देता हूँ, एंड दैट इज़ इनफ अबाउट ब्रेक्स एंड क्लचेस। ठीक है जी, ब्रेक्स एंड क्लचेस, हमने डिफरेंट ब्रेक्स एंड क्लचेस के बारे में पढ़ा, एंड वी एनालाइज देम फॉर द एक्चुएशन फोर्स एंड द torque, using the two models, the uniform wear and uniform pressure model, and I think that is enough for brakes and clutches. ठीक है जी, थैंक यू।